thank you for the introduction. So, our vision is that the data from all of those very different components related to a building can be stored and processed at a centralized location. And that there can be simulations performed on these data sets, that it has a graphical user interface, and that then applications can be designed which have an added value for different stakeholders of a building. For example, the building owners, the tenants, or the facility management. And with this rather abstract vision in mind, we were working on our project. In the following talk, I will first introduce the project, then I will talk about the use cases, which are the reduction of energy consumption, asset tracking, the PV self-consumption optimization, and evacuation. And I will end with a conclusion. So the project is an InnoSwiss-funded research project and a collaboration between our industry partner LICOM and 4 different institutes of the Zurich University of Applied Sciences. And LICOM specializes in smart building platforms, and on the right you can see the visualization of their software, which is called Eliona. And as the title says, in this project we focus on commercial buildings, and we want to create user assistance systems, and we define use cases and proof of concepts. So the first use case is the reduction of energy consumption. As you all know, buildings and commercial buildings as a part of it emit a large part of the global CO2 emissions, and therefore we want to reduce energy consumption of buildings. And what we want to do is to assist the facility management to operate a building in an optimal way, and for that we propose to use finite element simulations of a building, and because then these simulations are closer to the architectural plans and therefore simpler to set up than conventional models. The second use case is the asset tracking. Imagine a hospital where there are a lot of movable objects like beds or medical diagnostic devices, where it is very convenient if you always know where all these objects are at the moment. And therefore, the Institute of Embedded Systems designed devices and set up a wireless network to track objects and to additionally also measure environmental parameters. The third use case is the optimization of the PV self-consumption, while taking into account weather forecasts and the storage capacity of batteries from electrical cars which are parked in the building's parking lot. And the fourth use case, and here I have to say was, to assist rescue teams in case of an evacuation, because the project was based, or the idea was to use sensors which rely on movement, but if a person sits very still, then the sensors don't detect that person. And as it is an industry application, it needs to be foolproof, and therefore our industry partner said that the risk for this use case is too high, and then we had to drop this use case. So I will, in the following time, go into details for the first 2 use cases because they are interconnected. And the first use case, as I said, is the reduction of energy consumption. And we want to do this with integrating thermal simulations into the digital twin. And we propose to use a finite element simulation because then you can use material parameters and the building geometry directly from the building information model. And parameters like U values, thermal bridges, and the storage capacity of the building structure are then calculated, and you do not need to first calculate and then enter all those values in the model by hand. So, and in the picture, you can see a 3-story building, and the building structure. For the building structure, we use a finite element discretization. Then the radiation between the walls is taken into account. The airflow in the room is approximated by a lumped element model instead of a full fluid dynamics simulation to reduce computational time. Then the control algorithm for the HVAC system is also integrated, and solar gains through the windows are taken into account. And here we have a 2D model. The idea is to go for a full 3D model, but to reduce computational time, at the moment we have a 2D model. And as a proof of concept, we were able to achieve realistic profiles of room temperatures. And for those simulations, for them to be accurate, you need input data, and that's where this use case is related to the second use case. So here we have, in the picture you can see a low-power thread mesh network, and it consists of a border router which connects the thread network to the internet. And then you have the full thread devices, which are at the fixed location and also need a fixed power source. So they are often incorporated into lamps or power outlets. And then there are the minimal end devices. They are battery powered and therefore movable. And they have, on one hand, sensors which measure environmental parameters, and on the other hand can be used as tracking tags. So here in the first picture you can see such a minimal end device, and it is quite small and it uses very little power. So the battery life is 600 days if you take a measurement every 10 minutes. And the sensor density is very high. You can measure temperature, humidity, air pressure, volatile organic compounds, light, loudness, and you can also add a CO2 measurement sensor. And these data can then be used in a simulation. And then on the second picture, there is the full thread device. It receives, on one hand, all the measured data from the minimal end device. On the other hand, it also collects received signal strength indicator, or SSI, and with this we can track objects. So if the RSSI is high, the minimal end device is assumed to be in the same room, and otherwise there is a trilateration performed to locate the minimal end device. And as a proof of concept, we attempted 600 localizations. 75% of them were correct, and in 16% of the attempts, the adjacent room was localized. As a conclusion, we find that a holistic digital twin consists of many partial systems and also very inhomogeneous systems, which are then interconnected. That these partial systems generate added value by themselves, but also by supporting each other. In this project, we were closely working together with industry, and we found that there's a big potential for energy and therefore also financial savings in commercial buildings. Thank you very much for your attention.